Hello and welcome to NOV Live. I'm Michael Gaines and glad you're joining us as we continue our ongoing conversation with subject matter experts bringing you insights into leading technology helping shape the oil and gas industry. We are coming to you at a special time as we've got certainly special guests with us that are joining us today to talk about a topic that certainly is top of mind for many in the industry and around the world. So we'll be diving into the topic of geothermal drill bits and some innovative technology that's come from ReedHycalog and the team here at NOV. So certainly a conversation that we're glad you are going to be a part of. So speaking of being a part of the conversation, want to bring in Shelby Dumaine, who knows all things social media and is here to help us give you some insight as to how you can be a part of today's conversation. Hey, Shelby.
Hey, Michael. So if you're watching here at home, first off, know that you're probably my favorite part of the show, which is hearing from our audience. So thank you for joining us today. If you'd like to get involved with the show and ask your questions, or maybe even let us know what you're thinking, you can do so a couple different ways. So the easiest way is you can comment below, whether you're on Facebook, LinkedIn, or YouTube. I'm in the comment section throughout the entire show, reading everything you're saying. So you can comment all of your questions for our experts there in the comments. I'm seeing some now. I see Australia. I'm seeing Houston, Malaysia, Louisiana. That's awesome. Mexico. So go ahead and let us know where you're tuning in from. I love seeing where everyone is watching. And so after the show, if you have more questions and maybe more comments or even ideas for something you'd like to see on a future episode, there are also a couple different ways that you can get in touch with us. The first way is you can shoot us a quick email. So that email is socialmedia@nov.com. It's there on the screen now if you need that. And the other way to get in contact with us is actually by giving us a call. So you can call, leave a voicemail, let us know maybe your name, where you work, or where you're from, or you can stay anonymous. Absolutely up to you. And that number is on screen now as well. It's country code +1 346 223 4799. So those are all the ways to contact us. But I did want to mention something that's very exciting and brand new we have for everybody. If you're a fan of the shows, NOV Live that we do, or the Ask Assad show, which is the other show that we do here on our channels, we now have a way where you can watch all of those in one place, where you can learn about future episodes coming up. And that is at nov.com/live. So there it is on the screen there. If you go to nov.com/live, you'll be able to see all of our episodes, past, present, and even previews for the ones that are coming in the future. So very excited to see our website. Definitely check that out if you want more information. So anyways, now that I've covered all the ways to find us, all the ways to ask us your questions, now it's time for the part of the show where I ask you a question. So it is time for Rig Geek's Post of the Week.
Rig Geek's Post of the Week.
All right. So Michael mentioned the topic there at the top of the show that we're talking about geothermal and some technology in the space of geothermal energy. So that's a good clue for what our question is going to be about. So here we're going to bring it on the screen. The Rig Geek question this week is, what is the common name of the path along the Pacific Ocean characterized by active volcanoes and frequent earthquakes? Maybe I'll give a little bit of a hint just because I have to. I'm here from Texas in the U.S. and it also might be a popular country song. So I'll let you. I'll see if our Rig Geeks and maybe our country music fans also can guess the name that we're looking for, the answer for this week's question. And we'll reveal that at the end of the show.
Yeah, man. Well, if it was all up to me and country music, I think I would fail your quiz, Shelby. So you're really up in the difficulty here. But cool. Well, look forward to getting the answer for me here in just a little bit. All right. So as we've talked about, we're talking about geothermal drill bits and really geothermal drilling technology. And to give us some insight on what that means and how that looks and the innovations that surround that. We have two guests with us today. First, we have Hardy Walker, who is the Regional Director, Asia Pacific for ReedHycalog. And we also have Pawl Victor, who is the Technical Sales Representative here as well. So, guys, thanks for joining us. And for our folks that normally are traveling the world but aren't able to right now, could you both let us know where you are joining us from today? Start with you, Hardy.
Yeah, thanks, Michael. Basically, I'm in Australia at the moment. My region obviously is Asia Pacific, India. I'm normally located in Malaysia, but I'm currently in Australia at the moment.
All right. And Pawl, where are you dialing in from today?
Kia ora from New Zealand. I'm in the lovely city of Auckland, New Zealand. My area is usually Australia and New Zealand, but I've been limited to New Zealand recently with the COVID-19. But yeah, hello from New Zealand. Great.
All right. Well, glad you're both here. And maybe we'll stick the first question over to you, Pawl. So as we talked about, and as Shelby mentioned, we're talking about geothermal drilling, and today we're actually talking about the Phoenix product line for geothermal drill bits from ReedHycalog. But before we dive into our main topic, just for those that may be on the periphery or would like some insight from experts like yourself, could you maybe give a little bit of insight and ideas to what geothermal drilling is and how it's different, or some considerations when you're looking at that in the oil and gas space?
Yeah, sure. Good question. Ultimately, it's a pretty similar discipline. There's a lot of different parameters. Probably the most important one is the temperature. As it suggests, it's a very high temperature. Common geothermal wells will go up to 300 degrees centigrade or 570 degrees Fahrenheit. And that's a big issue for us with regard to picking the drill bit, the temperature that the drill bit's going to see. Also, they're characterized generally by hard rocks. Those hard rocks are generally very abrasive as well. So the bit is going into a very harsh and abrasive environment, that's usually heavily faulted. And the heat has quite often turned a lot of the rocks there to metamorphic rocks. So there's a lot of altered rock states as well, which is quite unusual compared to an oil and gas well. Geothermal wells tend to have a bigger diameter. We tend to drill the production section tends to be a big diameter hole. So in New Zealand, it tends to be a 12 and a quarter inch production hole. And then you've got a low pressure as well. Ironically, you've got some low pressure. Quite often the pressure is sub-hydrostatic because you've got a lot of steam down there. So it's extremely low pressure, but high temperature. A lot of those fluids as well, we're ultimately drilling for fluid, water fluid. They can be very abrasive, very corrosive, a lot of hydrogen sulfide in the water. And the production rates are very high because we want to generate water and steam to drive that turbine to generate the electricity from. So those are some of the big differences in the geothermal wells that we drill.
And sounds like some really challenging and certainly interesting formations to be drilled, which I would certainly suspect requires having really advanced technology in order to meet the needs in those applications. So Hardy, I know that in looking at applications, just like Pawl mentioned, that the ReedHycalog team came together and were able to develop a whole new line of drill bits to meet those needs.
Yeah, so basically in Asia Pacific, we are on the Pacific Rim, where you're getting obviously a lot of volcanics, a lot of earthquakes, a lot of hot areas. We start all the way from Japan, Philippines, Taiwan, Indonesia, and then down through to New Zealand. So because we are very geothermal prolific in this part of the world, we looked at coming out with a specific bit design, which is the Phoenix design, which applies to the requirements like Paul outlined previously. Basically, we designed this off our existing tectonic design, but with a drill bit, we look at the specifics of the application and then obviously look at changing parts of the design or modifying the design to make it specific for a geothermal drilling. We obviously, in doing that, we want to try and outperform the existing roller cone bits, which have a whole lot of issues related with geothermal drilling, and increase performance, in the drilling of these geothermal wells. So that's how we came out with the Phoenix design for our region, and obviously it's something we can apply in other geothermal regions in the world. East Africa, west coast of the US, and parts of Europe are also prolific areas where geothermal exists.
All right. So, anyone who is familiar with drill bits or has even come in contact with someone who knows that there is no lack of technology and innovation and attention to detail when you're looking at drill bits, especially when you're looking at bits from ReedHycalog. So to that point, Hardy, I wanted to see for those that are kind of pining in their seats, wanting to know some more details. Could you maybe share a little bit more about some of the technologies that have been incorporated into the Phoenix drill bits?
Okay, so good question. So obviously at ReedHycalog, we pride ourselves in the cutters. We're obviously the existing company that developed leached cutters, and I would say we're the industry leader in actual cutters, PDC cutters, in the range that we offer and the different applications. With a geothermal bit, obviously you can see on the screen now the variety of cutters that we offer. With the geothermal bit, Paul mentioned again that the rocks that we drill, metamorphic, volcanic. So they're very abrasive rocks. They're a crystalline rock. So we looked at the cutter design, and obviously there's been a lot of development over the years in terms of the ability of cutters to drill harder and harder formations. So we came out with the ion range of cutters. And as you can see on the screen, there's a variety of shapes and profiles. Basically, if you look at the shaped cutters that we've got now, we can point load a lot of the formations to make them fail. So that's the failure mechanism, which is similar to what a roller cone bit was. Previously, with existing PDC cutters, there was never shaped cutters, or if there was, they weren't to the quality of what they are now. So these cutters can withstand the thermal degradation that you see in a geothermal well, which has a lot of volcanics, as opposed to an oil and gas well, which is more sedimentary basins, so like sandstones and things like that. Perhaps if you go to the next slide. One thing we look at, obviously, is the heat buildup on a cutter. The first thing for a PDC, for it to degrade, is thermal heat buildup. So we model the actual heat buildup of the bit, and that allows us to look at the different cutter grades and the placement of cutters on the bit to avoid excessive wear that you see in a geothermal bit. So we have come out with a bespoke bit that has been designed for geothermal, looking at things like heat transfer, which is one of the main issues with the degradation of PDC cutters. I think perhaps if you could go to the next slide. One other aspect you obviously look at with geothermal bits is the cooling of the cutters. So primarily a lot of geothermal wells are drilled with a foam or an air or a mist, and obviously sometimes water. It depends whereabouts you're drilling and the customer that's drilling. But we've come out with these nozzles which are directional, which we can obviously cool parts of the bit based on the analysis we've done for the thermal degradation. So we can orientate these nozzles to the point where we can actually cool the parts of the bit which are going to see excessive heat buildup, which again we've previously not been able to do on earlier PDC bits. So this is another aspect that we've looked at in terms of the design of the bit specific for geothermal. Perhaps if you could go to the next slide. So other aspects that we've looked at the bit is you can see on the screen, they're called struts. They're basically high density impreg material. You can see them behind the primary cutters. So they're the actual cutters that are slightly grayer in color. These have the shape of an existing PDC cutter, but they're made out of an impreg material, just like a impregnated drill bit. So it's diamond grit formed into a cutter shape. These cutters are actually much more impact resistant than a PDC cutter. And we've developed these for strategic parts of the bit that would see excessive wear in a geothermal application. So these are just a couple of aspects of the bit that we've looked at to make it specific for a geothermal, which is what you do for all drill bit applications. You look at the specifics of what you need to do, and you look at the design that's going to be applicable to that.
All right. Well, before I go to the next question, for those that just joined us live, we're talking about geothermal drilling and specifically geothermal drill bits and the Phoenix drill bit product line from NOV, from the ReedHycalog team. So if you have any questions about geothermal drilling, about the Phoenix drill bit line, or about anything geothermal drilling related, we have our experts here who are going to be taking your questions in our Q&A portion. So if you have those questions as the conversation is going on, or if you've just had them tucked away in your mind for a while and always wanted to ask someone, feel free to put them in the comments section, whether you're watching us on LinkedIn, Facebook, or YouTube. And Shelby Dumaine will get to your questions in just a little bit. So we look forward to getting those shortly. So Hardy, I'll continue with you and talking about the, again, when we're looking at the kind of historically, if we're kind of looking in the rearview mirror, kind of history of sorts, what we would have seen historically is a lot of roller cone usage for a lot of volcanics and similar applications. Curious to know what the advantages of the Phoenix fixed cutter bit would be, especially when we're looking again at these geothermal or kind of harsh environments, right? I mean, that's really what it is. We're looking at these applications. Yep. What are some of those advantages?
Okay. Yep. Another good question. Basically, with how geothermal bit wells used to be drilled, they drilled with a lot of roller cone drill bits. A roller cone bit has a insert or a button on it, which basically fails the rock by compressing it to the point where it fractures. As the name suggests, a roller cone bit says that there is rolling elements in the actual drill bit. So for an example, a roller cone bit has a bearing, has seals, has grease, has rollers, roller balls. So all of those things are probably historically what was used, but moving forward in technology, you don't really want to be putting rolling elements in a hole that could be upwards of 250 degrees Celsius, I'm talking here. So, a roller cone bit was used historically because PDC cutters weren't of the, they hadn't progressed technologically. So historically, that's what a lot of people used. With the advent of being able to come out with shaped cutters, and a lot of these cutters are laser cut or to get the shapes. And we obviously look at the different diamond makeup that we've got in the actual bit. We've been able to come out with cutters now that can withstand the harsh drilling environments that a present in a geothermal well. And we're able to get the same kind of point loading to fail the rock with the actual shaped cutter. So we're getting the same thing you can get from a roller cone bit, but obviously with no moving parts. We have no bearings, we have no grease. We have a completely, as what they call, a fixed cutter bit. So that gives you many advantages. It means it can be rerun. A roller cone bit, you normally don't want to rerun it if it's been run in a very hot environment. The seals deteriorate, the grease dries out. Whereas with a fixed cutter bit, we don't have any of those issues. We can repair these bits. We can obviously change the cutters out, take the cutters out, put different quality cutters in for maybe a different application. Paul may outline in New Zealand, depending where you drill, there's completely different volcanics. So you may need one cutter type for one well, and then you may need to change it for the second well. And the fixed cutter bit gives you that advantage. As you see technologies change, you can change the cutters. So it's the repairability, it's the rerunability, and it's the ability to change the configuration of the bit just with the cutters. You sort of equate it to like a car. You can put a set of slicks on your car or to go racing, or you can put some wet weather tires on your car if it's wet. Similar kind of thing with fixed cutter drill bits. We can change it. One of the other aspects we're looking at the moment is mechanically retained cutters. So normally a cutter is brazed into the drill bit with a bit of solder, but we're coming out with designs where you can actually take the cutters out in the field and replace the cutters so they don't need to go back to a repair facility to have them unbrazed. So that's one other aspect we're looking at with the geothermal range of bits.
Yeah, that fits your car analogy quite well. That's really interesting.
Yeah, I like cars, Michael.
Well, I know I don't. I talk to many folks, and if I start getting on the car path, we won't get off of it. So I won't dive in. But that is really innovative. I like that concept. So Paul, I'll keep the analogy. I'll put you in the driver's seat here. So these are really interesting solutions that we have for the geothermal space. One that I think both of you know far better than I, that is continuing to grow in demand and opportunity. But at the end of the day, the technology is great, but knowing that it's been run, and even more so that there's some successes behind it, is certainly a lot better. So when we're looking at the Phoenix drill bit line, can you talk a little bit about some of the successes that you have had in the field?
Sure, yeah. Just disappointed you guys beat me to the car analogy, but yeah. So I've actually got. I'm not hugely strong. This is just this is a 3D. This is a 3D printed model. This is a success story. I'm presenting this next week to one of my customers at the New Zealand geothermal conference that we have, and So I've got two examples I'll talk about in New Zealand. We had our first customer had a very challenging 1,200 meter section that they wanted to drill. It was geothermal through a lot of I think it's the next slide, if the next graphic, please. Through a lot of hard rock. There was ignimbrite, which is kind of a pyroclastic rock. We had andesite, which is a lava or an extrusive rock, and breccia, which is a sedimentary rock made of volcanic rocks, like a conglomerate, but even more difficult to drill because it's very angular. So I was fortunate to run this bit, this is what this model is in the COVID lockdown. In New Zealand, and we had a massive success there. We drilled 1,203 meters, the whole section in one bit, and we had excellent ROP. We had a lot of challenges on this well as well because it was a directional well, so we had to avoid existing wells. We had to turn the bit, and we had to build and drop the bit, and it was quite a challenging profile to drill. We did that all successfully without any reason to correct the well bore, and landed the well exactly where the customer wanted it. The really good thing about this, if I could have the next slide, please, is when we pulled the bit out of the ground, I kind of had a bit of a sweepstake with the engineer on the driller on the rig. We had some money riding on the dull condition of the bit, and that was probably the only embarrassing thing on the whole job, was I actually lost my own sweepstake. I thought the bit would come out pretty used, but it actually came out virtually green. So you can see those cutters there and the HDIs that Hardy was talking about, and they're basically green, as we would term them. The cutters in on the shoulder there, they're the 40X shape geometry that Hardy mentioned. They're basically they're not worn at all after 1,200 meters of this very hard abrasive volcanic rock, which I'll be honest, did kind of surprise me. It was so good. And then you go into the center of the bit, or the cone of the bit, and you have the 3DX shaped ones. They're very efficient at failing the center of the rock where the revolutions are lower, and there was nowhere on those either. So we graded this bit 0-1, which if you know the IIDC code for grading, basically means that it sees very little wear, it's rerunnable. And this bit in the photograph is actually being returned, as Hardy mentioned, to a repair facility and being repaired to be 0-0 grade again for the next well. If we could have the next slide, please. Another customer in New Zealand that I have, they traditionally have the roller cone bits generally, go in early in the well, and this customer had a bit of a tricky problem to solve. They had a 21-inch BOP stack, which is an unusual size, so they needed a real bespoke size bit, which we were able to give them. They ran a 20 3/4-inch bit, and they were buying these roller cone bits from a manufacturer, and they were pretty expensive, and they were getting one use out of them, and then they'd have to retire them. You see those teeth on that roller cone bit are pretty beaten up, and that's not a rerunnable condition. So we made a PDC solution for them. If you could have the next slide, please. And that's the 20 3/4-inch Phoenix bit. That's a big bit, and the customer calls it the Kraken. I don't know if you know the Atlantis films, but the big sea monster in the Titans and stuff is the Kraken, and it does kind of look like a crazy squid coming at you in that photograph. But we've drilled with this. We've done 3 wells with this bit. It's kind of price model is on 10, but we've already seen that we'll be saving money for the client on the 4th well. And that bit is it's increased the ROP in the top formations by 100%, and the tough lithology has improved by 30%. So we're seeing much better ROPs through the section, and the bit after 3 wells has come out 0-0 as well. So we're well on track to achieve that 10 wells that the client is looking for. So that's another success story as well in the big PDCs. So we're able to look at these customers' applications and bespoke or tailor-make solutions for them as well. So if we could have the next slide, please. So that's the 20 3/4-inch bit in the Phoenix range. Obviously, the paint's come off after running it, but not much else has happened to it. So yeah, that's 2 good success stories in New Zealand. But obviously, we're in this Pacific area, so don't want to give the quiz question away, but another country in that area is Indonesia. And on the next slide, please. Indonesia has had some very good successes as well. Indonesia had a 12 1/4 application there for a client. And the client wanted to really drill this 12 1/4 production hole in one run. And they wanted to get good ROPs above 10. And the minimum requirement was 800 meters. And the bit actually very similar to this design, did 1,000 meters for the client. And again, if you could have the next slide, the dull was just incredible. The rig graded it 1-1, but as you can see that you struggle to find any wear on that. So it's whether it's 0-0 or 1-1's a fairly muted point. But the bit has done an amazing job. It ticked all the boxes that the client wanted, and then has been pulled. And then that green condition again, you can see the HDIs haven't worn. And that bit is a rerunnable condition again for the client, further saving them some money, and then where it needs to be can be repaired to A1 plus condition again for the client. So success story from our region there.
Yeah, no, and that's great. I love the fact that it's not only successes, but some in which you had boots on the ground and you were there personally, though. I can't say that you left with all the money that you arrived with, but that's another story. But no, that really is interesting. I love the ability to be able to share that perspective. You mentioned a word, Paul, that actually I wanted to push over to Hardy. So we talked about custom or custom designed or kind of bespoke, and it's something that I think I hear in all different facets of life, let alone in the industry, especially when you're talking about drill bits. So I'm kind of curious, how do you see these drill bits, the Phoenix line, really differentiating themselves in the marketplace?
So I'll use another car analogy if I can, please.
Sure.
A successful car company, when they introduce a car to a region, they'll get the local people to change the suspension or whatever it is to make it suitable for Australian roads or African roads or Middle East. They'll upgrade the air conditioning system or whatever it is. We basically have taken that analogy and done the same thing with it. Luckily, rocks, don't know which country they're in. It could be New Zealand, it could be Indonesia, Japan. It may have been formed slightly different way, the volcanic rock, but they primarily have the same crystalline structure. So what we've done is we look at things regionally. We have 2 design experts in Asia Pacific, and one is specifically experienced in geothermal. That's Mada Sultan in Indonesia. So we've had a look at designing it or changing or looking at our specifics of the drill bit for the region. For example, the cutter grade according to the rocks we're drilling, the hydraulics, cooling it. So we do actually specifically look at the bit design specific to the rock that it's actually failing. So instead of having someone from a region that does not have any geothermal wells, so is not experienced in the type of rock, we've localized it. So we've put our investment in the people, the local design engineers, and we've also put our investment in the cutters. ReedHycalog still is the industry leader in the cutters. The variety of shapes, leached cutters. So, that's sort of where it's a bespoke bit for the design. If it wasn't bespoke, we wouldn't have looked at the specific cutter type or the cooling or these impreg material, which is very useful for volcanic rocks. So that's one of the aspects that we've looked at. Also, we have very good relationship or very good understanding from the customer when we do a dull grade. Some of those dull grade is where you look at each cutter on the drill bit and actually look at how it's worn. And when customers allow us to look back at the drill bit, we can work out whether we need to change a cutter type in what's called the shoulder of the bit or on the nose of the bit. And we do a cutter by cutter grading. So then on the next time we repair the bit or the next design, we can actually change that cutter type. And that's very good relationship or very good understanding from a customer that we're a specialist in the field. Drill bits is ReedHycalog. We don't do anything else other than drill bits. So we specialize in making sure that bit is design specific for the application. I don't know, Paul, if you want to add to that from the local experience of the runs in New Zealand.
Yeah, sure. Thanks, Hardy. Yeah. So yeah, as Hardy alluded to, a lot of it is down to that real common goal, solution-orientated approach. I've been very fortunate here with the geothermal customers in New Zealand to be able to go to their facility, meet one-on-one with their drilling engineers, and really understand their goal. Because if I understand their goal, I can really apply that technology. I've been allowed to go into the customer warehouse and look at offset runs and take some very high density or high resolution photographs, which we can of cutters, previously failed cutters, which we can then get back to our engineers, and we can really understand the failure mechanism. Because generally a cutter will fail one of three ways. It'll either be thermally failed, abrasively failed, or impact failed, or a combination of those. And we can analyze the previous performance and capture that knowledge into the tailor-made or the bespoke solution that we're providing. And the other great thing about PDC cutter technology and PDC bits is we can iterate these new versions very quickly as well. So we, from well to well, we can capture those any area of weakness in the bit, and then have that amended for the next run. So, for example, this presentation 3D print is 2 iterations since this one was run, which are now in the ground, and they've solved some minor problems. We had some wear out on failure here out on these last 2 cutters on gauge, and we just put a stronger cutter in there and resolve that problem. So it's that real working together of a common goal, and the access to information and previous run data that we can then go and say, well, we understand why this has been failing in the past, and we can solve that in the future.
Great. Yeah, no, and I know there is quite, you said, quite a bit of innovation and experience, both from lessons learned in the past and certainly applications for the future. So appreciate that insight. And if folks are watching and want more information, you can head over to NOV.com, and in the upper portion of the screen, you'll see a search bar. If you just type in Phoenix drill bits, you'll be taken to the page where you can find more information and an article detailing even more insights that Hardy and Paul were able to talk to. So certainly appreciate the perspective. And now we're going to turn the tables and get the questions from viewers over to you. So to do that, Shelby, know that some of those questions were starting to come in. I saw them kind of a flurry just a little bit ago.
Absolutely. Yeah, they started rolling in, and love to see it. We love seeing our questions from the audience. So this first one I'm going to pull in is actually from a user on LinkedIn. They're wondering what grade of steel is used in the drill bits?
I can get one. So these bits that we're primarily running are matrix bits. So they're not a steel-bodied bit. When we looked at the design, obviously we've gone with a matrix that is very abrasion and impact resistant. So primarily the drill bits that we're running are matrix bits, not steel-bodied bits.
Okay, good to know. It's good. I like hearing those kind of answers as well. So this next one, I'm going to show it on screen as well. I love how he asked it, but he said 10 wells in one bit. Can you talk a little bit about the distance in hours?
I think that was referring to what you were talking about earlier, Paul.
Yep.
Yeah, so the 10 wells, cumulative, this bit's going to drill about 4,000 meters. So I believe that would be around the 13,000 feet in total. And then we'll, as we track along that cumulative curve, we'll there's a break-even cost there that is the first sort of milestone or hurdle. And then when we've got through that, the bit still has to be efficient. So if we will track that ROP, and if we do see that there's maybe some wear coming into the blades on the hard metal, and we see a slow deterioration of ROPs, then the client will basically maybe call time and either get that bit repaired or replaced. But the cumulative goal is 10,000 meters. Yeah.
Wow. That's awesome. This next one comes from Karen on LinkedIn, and she's wondering, are you using the drill bits in lateral sessions or horizontal sessions?
Generally in New Zealand, the wells tend to be vertical wells, or we are starting to see obviously land space is a virtue. A lot of these areas share the area with farming, and a lot of these companies are obviously very ecologically conscious of their actions. So we are seeing sort of drilling from pads, and so we're seeing more and more directional wells. They tend to usually be low angle and tangent sections. So we're generally seeing vertical and directional tangent wells.
Mm-hmm. Absolutely. So this next one, I wanted to ask you a little bit. I know you've talked several times about like the different regions, New Zealand, and some others where these can be used. Can you talk about maybe where else in the world or what other regions could benefit from these drill bits?
So primarily, we look at in Asia Pacific. We start in Japan, Taiwan, then the Philippines, and then it goes down Indonesia, New Zealand. Obviously, there's a big geothermal applications in East Africa, Turkey, parts of the Middle East, Iceland, and the west coast of America. So basically California, all through the west coast of America. Really, wherever you're looking for, wherever there's some hot springs or significant heat close to the surface or near the surface is suitable areas for geothermal. There are areas where geothermal is not going to be applicable, where the country is in the middle of a plate and you've got to drill way too deep to get to any kind of temperature. But they're primarily the regions where geothermal is applicable.
Excellent. So this next one, it actually came super early in the show, right there at the beginning. I wanted to pull that up. It's from Barrera on LinkedIn, and he's wondering, can you use a mud motor to drill these wells?
Yes, you can. In fact, the several of the runs that the first run I spoke about was with a mud motor, and that was a very successful run. The one where we had to avoid the existing wells. Yes, you definitely can use mud motors. As Hardy alluded to, some people actually use air as well and foam. So there's a lot of different technologies you can apply to specific geothermal environments. Yeah.
Oh, very cool. And so I think this will be our last question here that we got. Denny on LinkedIn was wondering, do you have small bits of the same type, for example, to be used in slim hole for geothermal?
So it depends on the size. In Asia Pacific, the smallest we really do in geothermal at the moment is about 7 7/8. But this technology is applicable to any hole size. We can design the same technology in a very small bit. In terms of ReedHycalog, we go down to 3 1/8 and even smaller than that in terms of PDC bits. So if there's an application, we can make an applicable bit for it using the same technology and design philosophy.
All right, that is I appreciate anytime I have a super duo who is willing to take a rapid fire questions. It always makes my day. So really appreciate it. And certainly when we're talking about really, and I just think an exciting space when we're talking about geothermal and what that can do, not only for the ReedHycalog team and drill bit space, but really just innovative ways of harnessing new or expanded ways of energy consumption. So certainly appreciate it. So it had Hardy Walker and also had with us today Paul Victor talking about the line of drill bits from ReedHycalog, the Phoenix drill bit line. So Hardy and Paul, thanks for taking the time to talk with us today.
Thank you, Michael.
No
Thank you.
And I know that we mentioned it earlier, but wanted to actually just demonstrate for you. If you want to find more information on these drill bits, just go to NOV.com and just type in Phoenix at the top, and you will be directed straight to the page that we mentioned, and you can find more information on these drill bits. So certainly worth the visit if you get the time. So before we roll out, want to go ahead and get back with Shelby Dumaine to get the answer for our Rig Geek post of the week. All right, Shelby. So you were, I don't know, you gave us a question with something about singing or country music or something like that. I don't know.
I did. We'll go over the question one more time. I asked, what is the common name of the path along the Pacific Ocean characterized by active volcanoes and frequent earthquakes? And of course, like you mentioned, my hint was that it's also a very famous country song. And I didn't want to bury the, but it's my favorite song by the artist Johnny Cash. And the answer is Ring of Fire.
There it is.
There it is. So yep, that's that region. Like I said, along the Pacific shorelines that have high volcanic activity. It's also a fantastic song if you want to look it up.
There you go.
And you know, you were mentioning the how to find more about the Phoenix drill bits online. And I'd be remiss if I also didn't mention one more time, because I'm so excited about the new web page for the live shows. If you want to find more about the live shows, you can do so at NOV.com/live. So we kept that URL short and sweet so that you could find.
Yeah, as a matter of fact, we're going to go here. I'll go ahead and bring it up. So here it is.
Beautiful.
In all its glory. And so look at that. So you can find not only the new ones, right? Is that right, Shelby?
Absolutely. Yeah. You can find the ones that are coming up that week. And then you can also see our backlog of all past episodes as well.
That's cool.
You can tune in there. And, yep. And if you have any questions, if you're watching a past episode and maybe you have a question about that one, but you know, it's past, so it's not live anymore, you can absolutely email us at social media at NOV.com. We would love to hear those questions as well.
Great. All right. Well, thank you, Shelby. Really appreciate that. And again, a special thanks to Hardy Walker and Paul Victor for talking to us about the Phoenix drill bit product line from ReedHycalog. So if you'd like more information, again, feel free to head over to NOV.com and search Phoenix, and you can find more information about this product line. So, of course, we always appreciate your feedback and insight. And if you'd like to send any questions, comments, or suggestions for future topics or technologies that we can cover here on the show, feel free to send us an email at socialmedia@NOV.com, and we'd be more than happy to dialogue with you. So on behalf of all of us here at NOV, thanks for watching and for listening, and we'll talk to you again next time.